Ladies and gentlemen, to kick things off, please welcome to the stage Ildiko Vancha.
Hi, good morning, everyone. I can see that we still have some seats, so I'm guessing that there are some people hangovered in that hotel room and they are feeling really, really sorry that they are missing the really, really amazing keynote block this morning about Edge. More of Edge and with a little bit of NFV flavor. So just to wake you all up, are you enjoying the summit? Hands up if you're having a good time. Yay! Are you ready to start this? Yay! Awesome. All right, a few questions to you guys. So I'm just wondering how many of you are here at this conference to just learn what edge computing is? You have no idea, never heard, trying to learn what that is. Hands up. Okay, a few of us. Great. And which of you are already working on it, having proof of concepts, planning on rolling it out? A few hands. Running things in production? A very few hands. All right. So good news that when our track chairs were working on putting together the content for the Edge track, we basically try to address all these things. So you will hear about what edge computing is. People will try to fill you in and make you feel comfortable in this area. There are a lot of presentations on some of the details like security in Edge, which I think is a very important topic whenever Edge comes up. You will also learn about how OpenStack projects are functioning or not yet functioning in Edge. So we have pretty great content for you for the next 2 days, but first we will start with this keynote block where we also try to show you that edge computing is not just a telecom/NFV/5G topic, but it's also for the wide industry. And also a really good opportunity for cross-community collaboration. So on that note, our first speaker will take you to the world of the textile industry. So from 99 Cloud, please welcome Shuchuan Huang.
Hello. Thank you, Ildiko, for this introduction and warm us up. I hope you guys can enjoy today's sessions. And my name is Shuchuan Huang. I'm from 99 Cloud. So at the beginning, I have give you a brief introduction about 99 Cloud. 99 Cloud was founded in 2012. We are the earliest evangelists of OpenStack in China, and we start our business in OpenStack training. So right now, we are the largest OpenStack training organization in China. Also, we start our contribution in OpenStack since 2012. We are contributing OpenStack regarding in the technical and community building. So we are the top 3 contributor in China and top 10 contributor globally. We use open source technology to enable our customer to resolve their real-world problems. We are members of OpenStack, CNCF, Linux, and many other open source community. Right now we have the largest market share of OpenStack in energy, financial banking, and other many vertical industry in China. Today, I will, first of all, let's look at the history of computing. As we all know, cloud dominates the IT discussion in last 2 decades, right? Particular with the Amazon, he released his EC2 services in 2006, and OpenStack come out in 2010. That is a huge event for the cloud computing. As we all know, cloud computing is centralized all the cloud computing services in the data center so that we can take advantage of the shared data center and use the economy of the scale to reduce our costs and improve the efficiency of our daily work. There are different types of cloud: public cloud, private cloud, hybrid cloud, and we can use the software as a service, platform as a service, and infrastructure as a service for the cloud. So what happened for the next 10 years for the computing history? I think edge computing is not the end of the cloud computing. Actually, edge computing is the natural involvement of the cloud computing. It's because cloud computing has to extend its scope to meet different requirements and fit the different use cases. For example, let's see, for the external factors like the smart cities and the AR, VR use cases, it required the cloud computing to have more capability to meet those requirements, especially in the industry 4.0. I will talk about it later on. And on the other hand, we can see right now the architecture of cloud computing, it has little optimized for the use cases, especially in the small footprint platforms and for the unreliable network bandwidth, high bandwidth network and low latency, such kind of use cases. So edge computing can bring our major 4 values to help to resolve all of these problems. For edge computing, we can have highly responsive cloud services. We can have real-time edge analysis in the IoT. We can also have more security in the edge side. Another thing is we can mask the disruption of the cloud services. So what does the edge computing do with the industry 4.0? Just as my understanding, I think the edge computing can act as a nerve ending of the manufacturing. What's nerve ending? Actually, for the nerve ending, it brings the intelligence to the manufacturing IoT devices. Without the edge computing for the manufacturing, all the IoT devices for the manufacturer, it may be just acting some simple actions. But with the edge computing, we can bring the real-time analysis and bring some intelligence pushing to the edge so that we can have the intelligence in the IoT devices. So let's take a look at the textile industry. To start the textile industry problems statement, I would like to introduce you the manufacturing process of the textile. I don't know if you guys know how we come with the fabric. Anyone know the process? Okay, it's great. Actually, the textile manufacturing process is a conversion of the fabric to is the fiber to yarn and yarn to the fabric. Okay, I looked the face with the confused, right? First of all, we will use the spinning process to bring the fiber into the yarn, and we will weighing the yarn. It will turn to the fabric, and we will dyeing and printing some patterns, some color or some pictures in the fabric, and will come out the finishing as a product. But we cannot ship the product to the customer. It is because we may have some defects in the fabric. So we have a very important step is the inspection. After the inspection, we can deliver the fabric to our customer. So for the traditional inspection process, it depends on the human. The fabric defect detection is very necessary, as I just said, because it's a quality control in the textile industry. And the quality inspection of the fabric surface is highly important before we shipping this product to the customer. Let's see what's the defect of a fabric. It's just like the picture shows. It's a flaw on the surface resulting from the manufacturing processes. So the human have to standing beside the machine and watching the fabric and find the fabric. It's a very high cost because the human labor, and it's low efficiency and not consistent and not stable. So for the traditional, we have this architecture to resolve this problem with some kind of systems, automatic system. There are 3 steps to help us to detect the fabric defect. First one is image capture. Second one is defect detection. The last one is the post-processing. The image capture procedure is majorly responsible for the image capture with some high-resolution camera. We camera a lot of the pictures of the fabric, and then we can run some algorithm, machine learning algorithm based on these pictures, a lot of pictures, and we will find if there are any defects in this fabric. We localize this defect and segment those defect regions so that the worker can help to reduce this, remove this defect later on. So the last procedure is the post-processing procedure. What's that? Actually, we will do the defect type classification and defect grade assessment and defect remove mode. In this traditional architecture, as you see, we put all the application in the central cloud. So when we're doing the image capture process, it captures a lot of high resolution pictures. We have to sending a lot of these images back to the cloud, so it's high bandwidth in the network. And in the post procedure, if we are going to control the machine to remove some defect, it will have high latency when the cloud sending command to the machine. So edge computing can help us resolve these kind of problems. We will set up another edge cloud environment besides the machine. It can be located in the workshop. One workshop have an edge cloud talk to several machines, and we collect the data from the machine and do the feature extra the feature from the image. And for the edge cloud, it's just sending the features back to the central cloud. And the central cloud, it can collect all the features from different workshops and run another further algorithm to help us to update the model, and then it can push in the intelligence to the edge side to update the model in the edge side. So as this process running again and again, we can have more high precision prediction for the defect. Also, if we are going to do some automatically defect removal process, we can use the edge cloud to directly control the machine in the workshop. So as a result, we're working with our partner. We have proved the velocity of these systems is about 5 or 6 times to the human's velocity. That's a pretty good start result. But we can also see, even we have this kind of edge optimized architecture, but we can only resolve some kind of fabric. For example, some color fabric or some specific pattern fabric. We have to optimize the application in the central cloud to improve we can recognize different types of fabric. And also we have to optimize the network between the central cloud and the edge cloud. For more information about this share, I welcome you guys to join the session tomorrow. I can explain in detail to you guys. Thank you.
Thank you, Shuchuan. It was really, really interesting. I always get really excited when I hear about our community growing all around the globe, and people are getting involved in all countries, from all cultures, and they are playing with OpenStack. It's also pretty great to learn about things which are not about IT, so I hope you got excited as well. A little bit of an administrative announcement. Please try to move closer to the middle of the row so people who are standing in the back can also sit down. Thank you. I mentioned that we will also talk a little bit about cross-community collaboration. There are around 20, 22 groups, open source standardization groups who are trying to figure edge computing out. And our next speakers will update you about Akraino. So please welcome on stage Melissa Ebershoot from Intel and Kandan Kathriwal from AT&T.
Thank you. Good morning, everyone. So we are very happy to talk about Akraino Edge Stack today. So I'm going to repeat some of the content that the previous speaker talked about. Why do we really need edge computing, right? So traditionally, for last couple of years, we've been moving all the workloads into a centralized cloud. Either it is a private cloud or it's a public cloud. We were all moving towards the centralized cloud. So the number of location of the centralized cloud, it is in the range of it starts from 10 to 50 in that range, right? The application which is getting deployed into this centralized cloud, they were not latency sensitive. They were able to withstand the latency of 25 to 200 milliseconds. So this is an average latency. Even though the centralized cloud has been deployed in a 50 or 100 location, it's still in the range of the 25 to 200 millisecond. So why do we need edge computing in that case? So the new application, there are a lot of emerging technology that is really coming up in the industry today. So NFV edge infrastructure, this is very important to understand. This is a telco use case. So 5G is really going to change how the telcos have been operating, how the users are experiencing the connectivity. And the 5G is being virtualized today, and that is actually going in edge computing. The other thing is autonomous devices. So we're going to see a lot of autonomous devices. Either it is a car, either it is a drone. Right now, there is an introduction phase right now. But over a period of time, in the next couple of years, we're going to see a lot of autonomous devices coming up in the market. The third thing is the immersive experiences. So we are using our cell phone. We are using actually TV to watch, let's say that, a sports program. But the technology is changing. And we may be wearing a AR, VR glass that is going to show us a 360 view of a stadium. And the fourth one is the industrial IoT. And there is many use cases for industrial IoT. All this application, they require less than 20 milliseconds. Why they require less than 20 milliseconds? The processing is really needed faster in order for that application to really support what's happening in real time. This is important to understand. So with that latency measure, less than 20 milliseconds, the centralized way of deployment across the globe, it is not going to support what we really needed to support this edge application. So the 20 millisecond, it is really the key. Is it all edge applications is really going to require 20 milliseconds? The answer is no, because even some application may require 5 milliseconds to really support it. And also there is a lot of data is getting generated at the edge. If you're trying to process all the data in the centralized cloud, what's going to happen is that the pipe that carry the data from the user, whatever the device is, towards that centralized cloud, we really need a larger pipe. Already the telcos are already supporting very large pipe to carry petabytes of data. With all these new devices coming up, new technology coming up, we really need a very large pipe, and that is a lot of expense for telcos, and it increases the cost how the consumer is consuming this technology. So that's why we really need edge computing. So how is this Akraino edge stack community is going to support this edge computing? There is really 3 pieces this Akraino edge community is trying to address. So the bottom piece, is the fully integrated open edge stack. So what does this really mean, right? So we have components from OpenStack, we have components from container, and there are many other communities developing operational tools. We really need a fully integrated stack in order to support the edge computing, because when we talk about centralized cloud, we talked about like 50 location or 100 location in that range. But when we talk about edge computing, it could be a very, very small box sitting in a cell tower, or it could be sitting in a customer location, or it could be a larger instance of edge cloud, which could be sitting in telco offices. So there is a notion that people think that, like edge cloud is always a smaller box sitting somewhere. It is not true. It could be a smaller box, or it could be a couple of racks of equipment sitting actually in a telco office or a provider location, or anything in between. In order to support the smaller boxes or this larger instance, now we are talking about, in order to support the 20 millisecond, we need a large number of locations to be deployed with respect to the edge computing. Even to deploy edge, like the centralized cloud in, like less than 100 location, it is complex. We need a lot of tools, and we need a lot of consistency in the open source to really maintain it. But now we're talking about, like a large number of locations. We really need a fully integrated platform in order to support it. And we all support open source. And in open source, there are many other components need to come together to really support that fully integrated stack. So this community will focus on that to deliver, irrespective of, like either it is a small instance need to run in a cell tower or in a customer location, or it is a larger instance it need to, like run on a telco offices. All this different blueprint, this community would address it. Then in the top, we can see that edge application. Okay, so without this edge application, the platform itself is not going to be useful, right? So there need to be an application running on this platform. So there need to be a way for open source way of developing this edge application. Either it is an NFV telco application, or it is actually a AR, VR based application, or any type of that edge application that we talked about. We need a place where we can actually develop this application. So this community would address that particular application development as well. So in order to have the platform and application to connect and communicate together in a large instance of like edge instances, we need a common platform API layer. And that is also very important, because if we don't have that abstraction of common API layer, then it is very hard to have the application working together with the platform, especially on this large scale. So this community would address that development of edge, middleware, and API as well. So if we look at this in a totality, so we got a platform, which is really all the communities coming together and integrating a platform which can actually deploy in an edge location in a large scale. Then we have edge, middleware, and API, which provide you that abstraction layer to connect, then the application. So in totality, this is what we're calling as an Akraino edge stack. There is a lot of community effort currently being carried out in OpenStack, and there is an OpenStack Edge working group, and then we have a lot of other activities happening in the other community as well. This particular community is really going to bring those people together in terms of connecting them and bringing these three pieces together and packaging them for the benefit of the industry, benefit of the user, and making this edge happening. One of the key thing I always hear, because we had Akraino Summit last week, and we had many sessions, and we had off-day mini summit last week. The one thing I hear about from the application people is, how do I support the application if there is no platform, right? If you talk to a platform person, they say that, like, how do I support it if there is no application? So it is really mutual, like work need to be done in order to support this whole end-to-end, edge. So this community is really making sure that edge can make it happen. And that's what this community is really about.
Thanks, Kandan.
Sure.
So one of the things that we really wanted to make sure was clear to all of you is that the intention of the Akraino community is that it's complementary to a lot of the existing upstream projects that exist today. So specifically, as you guys are probably aware as part of the OpenStack community, there is a lot of work going on in OpenStack today with a very active Edge working group to try to define the features and the capabilities that are needed within OpenStack to uniquely serve Edge. And you know, Beth's here, she's been leading this effort with many others, and this is critical work. There's a lot of other things that are going on in the context of the rest of the community as well, whether it be in OPNFV. You've seen announcements this week from AT&T around Airship, Intel's announcements around Starling X. There's a lot of other assets that are going to come to play to really drive the innovation and align the industry, and Akraino is intended to pull those together into unique blueprints that will serve the variety of use cases that Condon just spoke about. Maybe. There we go. So what have we been up to? This is a very new effort. You may have seen the announcement in February of the creation of the project. And then there's been kind of this rolling thunder of companies that have put their names up publicly around their participation and support. In addition, there is a long list of folks who are in the process of getting on board as well, including enterprise edge and industrial edge players. And we think that this is really, really critical, because if we're going to achieve the vision that has been established for this community, these APIs, these SDKs, need to work across all of Edge, not just telco Edge. We did have a meetup last week in Portland that Intel hosted, and we had a great, vibrant discussion. There's a lot of storming and norming happening with regard to the community and where we're headed, and it's all these voices working together that will really enable our success. And finally, we've had many conversations here at the OpenStack Summit, and those are going to need to continue in order to really advance this cause. And so finally, our hope is that it is in this community that we will be able to figure out how to move this forward. The vision of Edge is robust. I think a lot of people are really excited about it. But there's a lot of complexity that needs to be streamlined and sorted through in order to have the ability to scale across vendors, across distributions, but really enable these use cases across the globe. So we thank you for your attention and your support, and we look forward to you being part of the community and collaborating with us to drive this forward. Thank you.
Thank you.
Thank you, Melissa and Kendall. So far you learned a little bit about, okay, so let's start with the administrativa again. Please use this time to find a seat in the rows. Those of you who are standing in the room, there are a lot of seats that can be occupied. And now back to the track. So far you learned about what is edge computing, how it can be used in simple and easy real-life examples like the fabric for my awesome dress. You also learned about why edge computing is used and needed, what sort of use cases that are require something like edge computing. And you also got a little bit ideas on how OpenStack can be part of, and other OSF projects be part of a large full stack environment, how it can be integrated and tested as part of a future cross-community collaboration effort. And what comes next, that will be a little bit of a unique use case, because why would you put OpenStack into a data center when you can just take it with you? So next on stage is the guy who feels a little bit naked without his cloud with him. So please welcome Kevin Jones from Red Hat.
Thank you. Thank you, Odika. So as she said, I'm Kevin Jones. I'm from Red Hat. I'm specifically in the US public sector division of Red Hat. So we set out to solve a problem that our solution architects had, actually. When we go on site to customers, we don't typically get network access, which means it's really difficult to show our software portfolio when we have no capability to reach it. That means we need to bring it with us. So we had several requirements. It needed to be less than 50 pounds, fit in a rollerboard case so we could put it on an airplane. It needs to plug into a regular outlet in the wall, power it on, and have internet access broadcasted by Wi-Fi so that customers could get right on and touch our software. So when we did this, what we found interesting, and this is the little kit that we've come up with on stage, we found that this brings up a whole different conversation. It makes the software tangible in a way that normally, give me just a second. There we go. In a way that normally doesn't happen when you're just showing the software remotely. So we've started to discover all these different use cases that we weren't really aware of. There's a few we were conscious of in the marketplace, but a lot of these are coming out of the woodworks. So these are a couple example field kits that exist today. The one in the lower corner there that says DLT, we're actually working with DLT to build this and be able to sell this. So you order a single SKU, DLT assembles this kit, lays down the software, drop ships it to your location. But the commonalities in here is you need a small footprint, portability. Some use cases require ruggedization. So the idea of a small amount of sand infiltration or heat is a big example there. The other thing is we're seeing is the need for not only a compute-based cluster like that, but maybe a storage dense cube that could be delivered, or an analytics cube that has GPUs in the box. The most commonality between all of the use cases is low power requirements, and the same bits that run on the field kit are the ones that run in the data center. So they need to know that the applications that they have built and tested and validated are going to run when they're sent out into the field. So I'm going to talk through a couple of the use cases that we've come across. The first one is disaster response and recovery. And we're all at an IT conference, but this is not DR in the data center. This is disaster response in real life. So the idea of a hurricane or a tsunami, a tornado, these agencies and organizations have to send people out into conditions they don't know what the situation is. They may not have any network connectivity. They may need to bring their own network broadcast capabilities. They might have unstable power at best, if they have power at all. And then in total, you're aggregating multiple organizations. It's not a single organization. You have to put applications up that handle logistics and communications for these different organizations. So if they had more portable infrastructure and they can run the same software that they run in the data center on these edge kits, then they will know that when they get there, they will have the applications and communications that they need. The next use case is one we have known for a while, and there are many field kits out there for this use case, but they're typically very large field kits. This is the one that needs the ruggedization most, and these are military operations. So the idea of sending a kit out to a remote location, it needs to survive transport. It's going into probably a hostile environment, and the thing is, the responsibility of these systems are actually human lives. So both the servicemen and women that are out there handling the operations, but also the civilians that are in the area and are there to be protected. So the kicker here is that if you need ruggedization, you will typically sacrifice on portability, and the ones that need portability will sacrifice on ruggedization. So they're typically an either-or situation. The next one I'm going to talk about is cybersecurity. So this one is really interesting. I actually kind of fell into this one. I went out to San Antonio. We had a public reference last year from a systems integrator called Radiance Technology. And we went out to the 90th Cyberspace Operations Squadron, which is responsible for developing the cyber toolkits that are being used out in the field. And they wanted an agile platform, and they chose OpenStack for that platform. Now what happens is they develop these tools, they ship them out, test it at another location, and then they ship them to another location to train operators, and ultimately they send an operator out with a field kit, and he has to be confident that those tools will run the same way they did when he got trained in the data center. And so the idea here is to give the operator a kit that they can roll just like I did. It never leaves their side, and when they get there, they can plug it into the compromised network, and they can actually consider this little kit disposable now because it is compromised as well. So that is a really, really interesting use case that we have been working on, and it's significantly important because we need the good guys to win this war. The last one is near and dear to my heart. So this is the idea of sending commodity Earth-built hardware up into space So this is actually being tested right now. There are x86 platforms up in space right now on the space station, seeing how they handle zero gravity, how they handle the harsh conditions. You have to think about that you have very, very tight places you have to put these into. And at the end of the day, they can be lives of astronauts that are dependent on these systems as well. The other piece that we're working on right now as a world is getting to Mars. So what's going to happen is if we send this hardware, Earth-based hardware, up into space, it functions well. We're going to then validate the software that we've been running on Earth here in space, and then we will ship that ahead of the exploration to Mars. So the idea is that the habitats and the systems that are going to run there will be shipped before anybody else is, and they will be up and running and capable of being used before the human lives arrive. The kicker here is that there's a latency, so the response round trip from Mars is 14 minutes. So when Curiosity landed, it was actually 14 minutes before we on Earth knew that it had landed safely and was already rolling on the surface of Mars. So that's an important use case. There is one that I forgot about. This is actually a Red Hat use case as well. So there are many people that send out on-location training. The way Red Hat does this today is we ship 1 to 4 Pelican cases full of laptops. Those laptops are obsolete almost the day we buy them. They're always under-resourced. The instructor has to arrive probably 2 days in advance because they want to get there so they know that if they have any hardware issues to deal with in those laptops, they don't know what the state of them are from the last one they were at. They have to re-image the systems. These are isolated networks, so when we do our certification and exams, when the student environment, they're not allowed to have internet access. So everything has to be in the environment in the classroom. And the other thing is the student experience is not great because at this day and age, to run what I have on that kit in a laptop, you'd have to have a minimum of 64 gigabytes of RAM, and you wouldn't even be running the applications on top, you'd just be running the infrastructure. So it'd be way nicer if the instructor could just roll this kit into the room, plug it into the wall, power it on, it broadcasts a network in there, the students bring their own devices, connect to the network. He kicks off a playbook when he starts the class and creates however many student environments there are. OpenStack happens to handle multi-tenancy very, very well by default. So this is a great, great use case for us even internally. The last thing I want to talk about is one I was working on 2 weeks ago. So I was sitting there trying to figure out what I was going to present at for this. I have a session tomorrow at 3:30 talking in more detail about some of these use cases. And sitting there working with my friends Ken Holden and Laurent Dome there, and one that's not pictured named Joe Ankoviak. But Red Hat intends to drive this truck around the US, continental US and parts of Canada for the next year. And so the truck has to have WAN connectivity when it has cell access to towers. So we had to build a whole network for this truck, and then we had to have enough infrastructure for the 40 students that can be housed in that trailer. So we want to do demonstrations, customer site visits, conferences, and that kit, the picture of that kit is the one sitting here, obviously, but there are 3 of those in this truck now, and we have created push-button deployment for that. So you actually plug the kit into a Pixie network, it Pixie boots the build node, and from there, Ansible deploys everything else. It takes about 3 hours to have full Red Hat Cloud Suite plus the applications running on top. So it's a pretty awesome use case, and I was sitting there thinking, hey, I'm building one actually right now when I haven't even prepped my presentation for next week yet. So anyway, this is the reason I came in. Jonathan saw my presentation for tomorrow and asked that I come out and talk because there are many, many other use cases beyond the telco use case that we all know and love today. So I just wanted to share a few that we've stumbled into. So thank you very much.
Thank you, Kevin. It was amazing. I have to tell you, again, please find seats, sit down, don't stand in the back. We are still having a lot of interesting sessions ahead of us. And back on track. So just a little personal detail, I always wanted to be a truck driver, so I don't know if I have enough of IT, I might ask Kevin whether I can sign up to drive that amazing one that you just saw the photo of. So now you just we just got a few steps further in real life and also one step into sci-fi movies. So, well, I at least used to write some code to OpenStack, and I always think that, oh yeah, maybe I messed up something, someone will find the bug, we'll fix it tomorrow, next week, or next year. No one's gonna die, I'm not a surgeon, so all good. But when you think about disaster recovery and taking OpenStack in a little box somewhere where people's lives depend on it, if I screwed up something in a software, then it really gives you a different perspective on IT and what we are doing here. And the other thing is, like, imagine OpenStack in space. Isn't that super cool? All right, so next up, I used to work with Curtis in the telecom working group a while back, and now he, with his colleague, will talk to you about, well, boxes, but for networks and network slicing. So please welcome on stage Curtis Collicott and Corey Erickson from Interdynamics.
Good morning. So as you can see up there, both Corey and I are OpenStack architects or OpenStack operators. So we work in the NFV space, and in doing that, we are curious about things like 5G. And when you start looking into 5G, we start to find things like network slicing. And what we wanted to do was to take a look into what 5G network slicing is and how we could participate using OpenStack in a network slice. So today we're going to talk to you about a little bit about 5G, a little bit about network slicing, and how we could deploy a VNF into an OpenStack cloud and have some sort of have it participate in a network slice in some capacity.
There you go. Okay, so we've had a lot of talk about edge computing and what that's going to bring. I want to just touch on some of the things that some of our colleagues have already touched on. But we're about to see one of the largest transformations of the network that we've had to date. We're going to see virtualization and slicing becoming more predominant as we have to try and support some of these edge use cases as we go forward. We've heard some talk about APIs needing to have a standardized API so we can control components of the network that aren't necessarily ours. We need a way to communicate with other network providers. Harmonized protocols and of course exposure to third parties as we're building out. We've listed out some of the often stated performance requirements, which are pretty insane. We're about to see 1,000 times the traffic demands. We're expected to be able to see 10 gigabit peak traffic to some of these mobile devices on the edge. Sorry, I'm having some technical difficulties here. Okay, so here's a couple of images that Curtis and I came across as we were doing our research. We thought they were rather interesting. So the one on the left you're going to see is a representation. The inner green area is what we have as 4G today, and you'll see that 5G is just an expansion all the way around of all the requirements to deliver that. So and the one on the right is depicting what some of those requirements are in relation to some of the major use cases that we've heard about today.
So this is so in order to understand what network slicing is, we had to read a lot of documents. At the end, I'll actually provide you with the bibliography because there was somewhere between 80 and 100 documents that we read to try to figure out what network slicing is. So when you're doing that, I came across quite a few diagrams that I like. This is probably one of my favorite diagrams because of network slicing, because it shows different slices, but it also shows the NFVI infrastructure where, which in the context of this summit would probably be OpenStack. So you can see we have a core cloud and an edge cloud, and those are places where OpenStack could participate in a network slice. So again, I mentioned there's all the documents you read. There's so many documents because there are so many standards bodies that are working to define what network slicing is. So like you can see, there's just a large number of standards groups and bodies, and they all have an opinion on what network slicing could or should or will be. So when we went through all those documents, we came up with a few words or phrases that I saw over and over and over again, and these are, and we kind of turned these into what we considered to be requirements for network slicing. So these aren't like official, requirements, but these are words and concepts that we saw again and again as we read through all these documents. So end-to-end orchestration, on-demand. Flexible. Probably one of the more interesting ones is that we have to expose these network slices potentially to third parties. Potentially multiple operators would participate in a network slice. Network functions are part of slices. Also an interesting part is the idea of recursion, where potentially a network slice could be made up of other network slices. So there's all kinds of interesting requirements and demands that could be that are required to potentially define what a network slice is. So obviously, network slicing is not necessarily part of the ETSI NFV definition, but probably to do network slicing, we're going to require NFV and probably some sort of software-defined networking as well. But it's not necessarily part of the ETSI NFV definition. This is probably my second favorite diagram. I like this one because it shows that a VNF, so the VNF would be virtual network function, that a slice could potentially be made up of one or zero, one or more virtual network functions, right? So not only is it like a virtualized network, maybe some sort of quality of service, but there could be network functions that are part of it as well. So in this particular ETSI document, NFV EVE 012, they tried to define where, so we know that OpenStack is typically made up of in the green box of the NFVI, the NFV infrastructure and the virtual infrastructure manager, but where would a network slicing component fit into? And in this diagram, we kind of put it out, separate it out, and there's some sort of separate function that performs network slicing.
Okay, so really quickly, as we were looking into this, we had to look at the entire OpenStack suite of products and projects, and we came across some that we feel are very related to what we need to do with network slicing. So this is a list of them. We're not going to go into them in too many detail. We don't have enough time. What we're going to focus on here in a moment is just a very quick demo that shows the Neutron QoS features in OpenStack today and how we can orchestrate those.
Neutron has a couple of different ways that you can apply quality of service. Like the two that we have up here are maximum bandwidth and then also DSCP markings. The demo that we're going to do uses OpenBaton, and in particular OpenBaton's network slicing engine, and that engine can apply Neutron quality of service policies to when a VNF is deployed.
Okay, so here's just a real quick diagram of the OpenBaton architecture and where that network slicing engine might sit in relation to your Vim and your NFVO. Okay. So just very quickly, using OpenBaton, we're going to instantiate a single VNF into the OpenStack POP, and the VNF has a predefined descriptor which includes the QoS policy requirements. The VNF will then register with the network slicing engine, receive notification, and then that will have the QoS policy. The network slicing engine will then ensure that the QoS policy exists, and if not, then it will create it. And then of course the policy will be applied. So we'll see if we can make this go. So on the top left, we are monitoring the OpenBaton. Of course. Okay, so on the top left, we're monitoring the, wow, we just did this several times this morning.
So I should say that we did this talk earlier this week, so there is actually a recording of...
There is, yeah. Okay.
So if you want, you could probably, it's probably up already, and you can find it and you can actually see the demo running. But what happens essentially is that we deploy a VNF using OpenBaton, and part of that VNF definition has a quality of service policy. And when the VNF comes up, the network slicing engine will actually apply that neutron quality of service. So unfortunately, we couldn't show you it, but you know, I guess the demo gods did not help us out very much today. But there is a bibliography, so we put up all the documents that we found related to network slicing. You can check that out. Thanks to the OpenBaton team, we did a lot of work with that particular open source project, and it was very useful for us to be able to explore what network slicing is in the context of OpenStack. And I mentioned we did the talk earlier this week. We already got quite a bit of good feedback, like some critical and some positive, and we learned quite a bit. So if there's people in the audience that have things that they could let us know about network slicing, it'd be awesome for you to send us an email. And other than that, thank you very much.
Yes, thank you.
Thank you, Curtis and Corey. And it seems that we are a little bit cursed with demos on Keynote stage. But well, you still learned a lot about 5G, the changes in order of magnitude, and what requirements things like connected cars bring in, and how you solve them when it comes to the network, when we are getting closer to the wire. So a little bit further on that, we are still staying with NFV. So Swisscom case study will be presented by a gentleman from Swisscom AVI Networks and HPE. Swisscom is a market leader IPTV provider, and they take carrier grade for media really seriously. So when they say 0 packet loss, that means 0 packets lost. So please welcome 3 gentlemen on stage who were so kind to me that they let me just tell their first name to you. So please welcome Misha, Marco, and Ranga on stage.
Good. Hi, everyone. We are really excited to be here. Thanks for having us. Past several years, Swisscom is investing heavily in researching for what we call the next generation cloud and implementing next generation cloud in its private networks. In one of its NFV implementation, we are here focused on that, not on edge computing. We are trying past years to create a runway for all our entertainment services. We had really some unique challenges which we are hoping you will benefit from after today's keynotes, and please, if you have your interest to find out how did we implement that, today at 11:50 we will be diving into the technical details of that implementation. Gentlemen on my right side, Renga and Marco, will give at that session detailed description and implementation details. The agenda is not for now. I will just be very short. This is the agenda for the session later. Take a note. If you're interested, please join us. This is how market sees us in Switzerland. We are the #1 in the IPTV market. We are owning the most of the customers in overall TV market in Switzerland. Some of the numbers might be interested for you. We are recording all our channels in the cloud. We are now growing like 25 petabytes per year. At the moment, our size of our storage is 90 petabytes. Streaming goes out to 2.8 terabits unicast streaming in a peak. We have absolutely passionate team behind all these numbers. We are working since 2006, where this product is live on market, and we are in front of implementing the 3rd generation, or if I may say, 3rd revolution of the TV experience on Swisscom. Before I dive into the details, where we will be in the future, just want to spend a couple of minutes explaining you how the chain of delivering of the TV service works today in Swisscom. So this is very high level picture. The environment, the cubes are presenting different subsystems. The red arrows are presenting the multicast traffic within the TV environment. Our service is a channel, and it is, the whole environment is, there are some restrictions what we have. There are multiple vendors ruling this environment without any APIs. There is a lot of manual work. Deploying the channels today requires up to several months of time. There is a lock-in in all of these components in the vendor lock-in, so they come with their own management system. We have to deal with them. Multicast is heavily used. This is not pure unicast environment. It is a legacy network setup due to the requirements of operations. The unicast and multicast traffic is separated, so we do not have a possibility to have single network interface, or we are kind of binded with these requirements. Extremely or high quality network is required, not as much as the high bandwidth, but high quality, no packet losses, no jitter, no delay. Also, as I said, provisioning of the channels can last quite long. Just for the sake of NFV topic, the components which we are trying to migrate, or what we did already migrate into the cloud environment, are transcoders, probes, rewrappers, muxers. This is something which is typical for the IPTV delivery chain. Now, this is how we see our future. The red squared devices are already migrated into the OpenStack cloud. And it's the interesting thing about is that we are using multicast within the cloud environment. Our vision is that Swisscom NFV streaming platform to enable vendors to compete with their features, pricing, and quality. We do not allow vendors to come in with within this environment with their own ecosystem. No vendor lock-in is also achieved by implementing policy of allowing several vendors to be available there. So there is no premium vendor there. We work with our vendors today as partners. We do not buy their products, we develop that together. What is interesting about this red squarish environment is that first step is achieved. This is a productive environment. We have several hundred of compute nodes running 130 live channels, and until this year we are planning to grow up to 300, and my personal wish is that we have almost more than 50% of the channels there, like 450. And we are talking all about multicast and streaming. When we look at our vision, this is the Swisscom vision, where we will go in the future. We, of course, I mean, to meet our strategy to reduce operational costs and evolve into the virtual world, cloud-based technology, and idea was born that we migrate all these services to the cloud environment. So all these small squares are actually presenting the VNF managers. Overall orchestration is foreseen. The idea of this picture is to show that we want to enable the business owner to deploy the channel within the minutes and instead of months. Virtual head-end is already implemented, is up and running in production. We are using AVI as well, heavily. All the rest of the VNF managers are to be integrated. Like everyone in this room, we have an aim to reduce operational costs, shorter time to market, no vendor lock-in, introduce new technologies to enable us to grow, and one thing which was really important for us in the area of transcoding, avoid using proprietary hardware, run everything on the off-the-shelf hardware. So far, our business case works out. Me, as an engineer, I'm absolutely excited to implement OpenStack and to dive into this technology, but as you know, without the proper business case, this wouldn't work. As the last message which I want to give, there are some challenges which we have along the way. There are three areas of challenges. There are business challenges, as I mentioned, challenge to create proper case so that channel can be deployed with less cost. We've proven to work, or the business case is proven. We have these channels running. We already see the benefits of it. Then there is a technology challenges which we have, and one of the biggest ones which we have in the past several years is unknown unknowns. So when you start one project, you already know what you know what you don't know, but for us the biggest challenge is we were entering into the areas which are completely unknown, and we could not predict that they will come, like creating zero packet loss inside environment. And not talking about some percentages, it really means that we are measuring several days without any zero packet loss for the specific bandwidth for the channels, because any loss of the packet on the source means also the bad experience for the customers. Maybe you are wondering what is this wave at the end. I want to talk about that as a third challenge. That's a social and organizational challenge what we have. I mean, we talk here about technology, we are all excited, we are all engineers, that's absolutely fantastic. But social organizational challenge amazed me how much impact it had on the project. And one of the project supporters and sponsors of the project compare the project, that's a wave, the great wave of Konagawa from the Japanese artist Hokusai. And the wave was meant to show the impact which such situations in life have on the real life, on the real people, on fishermen or people living off the coast of Japan. For us, Media Cloud is that great wave. It's challenging the whole landscape of the TV. What we did, we killed the lock-in, we automate everything, we alter everything faster. We do not allow suppliers to control the TV environment. We are pushing. We believe that we are pushing the future TV environment in the dimension when we, as an organization, can control. Thank you very much for your attendance. Thank you for having us. Join our session today at 11:50, and let's look how did we achieve that. Thank you so much.
Thank you, gentlemen. So you just got an example, another angle from everyday life. You just go home, sit down, turn on TV, simple and easy, right? And then you take a look at the architecture, the large numbers, the requirements, and how much work goes into it. Then it gets a little bit of another perspective. And it was also a really great example of how users get more involved with the development, integration, and maintenance process with using software from the open source ecosystem, including OpenStack. So far we went through a wide spectrum from everyday life examples to how this whole thing realized in a bit more technical details, what we need to do to achieve all these use cases and being able to put on all these scenarios. So now we will come back a little bit to the cross-community aspect. OpenStack has a really fruitful history with OPNFV, and now there is a new Edge Cloud project in OPNFV, and Fu Chao from China Mobile will fill you in with the details.
Thank you, Intego. I'm Fu Chao from Channel Mobile, and also I'm the TSC member for OPNFV and the PDL for the Edge Cloud project. So today I would like to bring more of the information of this Edge Cloud project, and hope you will be interested. So there has been lots of introduction and discussion about the multiple services. Actually, it happens in Edge. With the emergence of 5G, we expected that there will be lots of services with the requirement of low latency and high bandwidth, leading to huge demand for this Edge Cloud. And for OPNFV, you know, the initial goal of this open source community is to focusing on the reference platform design and architecture design for the NFV cloud. So we kind of look into whether Edge is also a scenario for OPNFV. So we see that where is the Edge cloud? We see that we try to give a network structure for the telco cloud, and we see that from the customer premises, the UE probably for mobile network, and all the way out onto like access central office, county level central office, and city level central office. All of these probably should be in the scope of Edge Cloud. These Edge Cloud, we already have lots of central office for the telco operators already located there, and we could have parts of them these central office to be redesigned easily to fit into the Edge Cloud facilities. And we also did some statistic surveys on the latency and bandwidth to see if these central office could meet the requirement actually for Edge services, and we got this results. The result is like we probably will have around 2 milliseconds of latency at the access point, but it will be around 4 milliseconds of latency at the city level. So you can see that almost at whatever level it is, it almost could meet most of the requirements of the services staying at the edge. And also we did some survey on the bandwidth. When we see that for 5G, most of the operators will improve their bandwidth to 50 gigabits at the access till 200 gigabits at the city level. So that will meet the high bandwidth requirement for most of the Edge services. So based on all these kind of analysis, we see that Edge should be quite important scenarios in the future for telco cloud. So we also see lots of things happening in the community. I think that lots of you will be aware of the things happening in all these open source communities. We see the EC working group in OpenStack. We see the newly announced project for Akraino. We also see a lot of Edge-related automation projects in ONAP. We see that also in the standardization organizations like in SCMAC, they have their technical reports, a lot of ongoing work about the Edge, and lots of things going on in OPNFV as well. There are lots of existing projects in OPNFV. They are not fully focused on the Edge scenarios, but they already have some use cases related with Edge, and already have some thoughts about the requirements of Edge. Taking Auto as an example, this is a project in OPNFV actually focusing on the integration of ONAP with multiple VMs. And they actually have a typical Edge use cases. They use virtual CPE as their applications for Edge, and they try to build the integration of ONAP with OpenStack and Kubernetes to provide the Edge infrastructure for the virtual CPE applications. And also we have our new CRM project, which is set up last year. And this is a kind of a typical application stay in the Edge that will provide lots of requirements for the Edge stacks. And there are two projects actually focusing on containers, which is Container for NFV and Clover. And the Clover projects kind of focusing on the applications that are containerized, and they also have lots of requirements for the Edge stack that should provide with these applications. And also the Container for NFV project, they are focusing on the integration of Kubernetes with OpenStack, and We also have our Ferris Lab, which is building the whole infra of the testings and CI/CD system of OPNFV. And these projects, they also have some considerations for Edge. But we kind of realized that there's a new project that is needed to be focused on Edge that could make the connection with all these different projects to work out the requirement for Edge and build out the reference platform for Edge specifically. So that's why we will begin the discussion of this project and set up this whole new project. The purpose of this project is to focus on the NFV platform integrated for telco edge cloud. It should be a platform edge, which is, we hope it to be homogeneous with the core and orchestration point of view, but so that we could have a unified orchestration and operating mechanism used from core to edge. But this edge platform should be better trimmed to meet the specific needs for edge services. So what do we plan to do? We kind of want to trigger this work into 4 aspects. First, about the requirement analysis. Like what I said, we have lots of use cases, we have a lot of work ongoing, but actually we have to put it somehow into a requirement analysis and architecture design. We would like to analyze and conclude the requirements for multiple services we see, not only telco, but also IoT business, or even in the factories and a lot of vertical industry. And also we would like to try to translate these requirements of Edge into the actual deployment requirements of this platform, like NFV SDN components, OpenStack, Kubernetes, hypervisors, virtual switch, hardware, and etc. And then the initial goal actually for this project eventually is to provide a reference platform design. We would like to design and release a limited number of OPNFV scenarios for Edge Cloud, which will take in consideration of the requirement analysis above. And then also about upstream collaboration, OPNFV is also always good at doing the upstreams collaborations, because we are integration project collaborating with lots of upstreams. So we also like to collaborate with other related communities for requirements and also the scenarios we're working on. And hopefully we could output the detailed requirements for components to each relevant projects. So for example, if we through the kind of analysis of all those Edge services, probably we would work out some specific requirements for OpenStack, and hopefully we could, through the collaboration with the OpenStack EC working groups and other projects, we could kind of output these requirements to the OpenStack community, and hope we could eventually integrate them back into OPNFV. And the last is the testing. OPNFV has done a lot of work on the testing. We have a bunch of testing tools and testing frameworks which we could reuse for the testing in Edge. So these are actually the 4 features we think that in general we should define for Edge Cloud. The first is lightweight control, which I guess it has been talked a lot in this morning. We're thinking that taking consideration of the limited space and powers that we have actually in the Edge central office, probably we will see that it will be unnecessary probably not to deploy orchestrator and VNFM, and also the VM and SDN should be lightweight as well. And the second is about the remote provisioning, which is also talked a lot this morning. Because Edge Cloud, they are rather distributed, and we could hardly expect to have a cloud experts there try to maintain the remote Edge Cloud, especially at the county level and the access level. So probably the remote provisioning is important, so that we could have some cloud maintainers sitting in the city level and could maintain all the clouds at the county's access and even at the customer premises. And the third is about the resource heterogeneity. I guess there's not that much talking about this morning, but we see that taking consideration of the multiple types of services that will sit in the Edge, telco services, IoT services, MEC, a lot of different resources will be appear at the edge, like VMs, containers in bare metals. They will be all coexisted in edge. Well, this seems like this is not a huge problem, but it will mean that the edge stack should have the capability to managing all those heterogeneous resources, and the whole manual workflow should also be worked out. And the last thing is about hardware and software acceleration. I noticed that there's not much addressed this morning, but I guess if you bring lots of user plane services onto edge, they have a huge demand actually for the packet forwarding, which will require hardware and software acceleration. Also, if we open this infrastructure to a lot of third-party MEC applications, there will be AI applications here, lots of applications that will require compute acceleration as well. So it is expected that there will be lots of acceleration resources located at edge, FPGA, GPU, lots of them. But I guess there will be two aspects of problem here when we're talking about acceleration at the edge. The first thing is about how actually we should expose these resources to the upper level, so that when the orchestrator trying to deploy some services at the edge, they should actually know what kind of resources can use and which node they should actually use for specific acceleration resources. And another thing is about unified API, which we begin the discussion in OPNFV, is that so that we could fully decouple the VNF services, the applications with the acceleration resources. So these are actually the four aspects. We think that edge is different from core, and we think that the edge project will focus on in future when we are doing the architecture design, the scenario releases. We try to work out the edge cloud architecture, but it seems that this is a quite complicated architecture, and taking consideration of so many heterogeneous resources here. We see that there will be commandery servers and customized servers, and there also will be physical network functions exist at this level. And also there will be VMs, containers, bare metals, all coexisted at this level. So it could be complicated. And also we have lots of discussions on the edge cloud resource management architecture. I won't give too much details here, but we're kind of thinking that the multi-region for OpenStack and also the lightweight OpenStack should be quite important for this whole solution of network management here. Talking about upstream collaborations, we have lots of communities that are working on edge, and we hope that we could put these requirements go to the upstreams through close collaborations with upstreams, and also we will continuously integrate all of the upstreams to the so as to deliver the typical scenarios for edge. And for OPNFV projects, like I just talking about, we also built a lot of close connection with them, hoping we could cooperate within OPNFV to help build the whole reference platform into it. And there's also something I should mention that previously in the Ferrous lab, we actually have no specific edge hardware, and this is something that we are ongoing work with the Ferrous projects. And progress for this projects. This project actually will have a lot of discussion in the OPNFV community, but it was first discussed in the 2018 ONAP OPNFV Developer Forum, and then the project was officially on board on April. We have our G release happen probably in this September, I guess, and we will have our first release scenario, which is the ONAP orchestrating with Kubernetes OpenStack. And I also give the wiki page here and meeting minutes here, so that probably you will be get more information for the progress of this project. And that's all, and you are very welcome to join us. Thank you.
Thank you, Fu Chao. It was a great summary on OPNFV and the edge activities, and you got a pretty great idea on how we will be able to collaborate with that group. And Fu Chao already mentioned ONAP, and we have Chris Donnelly with us, who's, among many things, leading the architecture group, and we'll talk to you about, in a bit more details about ONAP today.
Hi, I'm Chris Donnelly from Huawei. as Ildiko mentioned, I am the chair of the ONAP Architecture Subcommittee. For many of you who are not familiar with ONAP, it's the Open Network Automation Platform. It was formed a year ago from the merger of OpenEComp and OpenO orchestration platforms. And it looks at the Etsy Mano infrastructure and then expands beyond that, including SDN networking and full automation and inventory. We are currently working on our second release, which should be out in just a couple of weeks. And we were named Rookie of the Year, Open Source Rookie of the Year by Black Duck Software for 2018. We have a very active developer community. In the last year, we had 580 different authors touch the code base and over 26,000 commits. This is as of last week. Going forward, so here's the architecture that we are building in our Beijing release, which will be released in about 2 weeks. We have a design time environment for creating new services, and then also a separate runtime environment that includes the service orchestration, as well as a series of controllers for applications and network configuration. We have a full policy framework and an inventory system, and then analytics, data collection and analytics engine as well. We do currently deploy all of our VNFs on top of OpenStack or on top of VMware. We are in the process of adding support for Kubernetes and also public clouds. We have a VNF onboarding program that provides packaging tools and validation tools for new VNFs. Up to this point, for the first 2 releases, we were not considering edge cloud deployments. We were focused on deploying at the central sites. We have recently spun up an ad hoc working group to focus on edge cloud and to bring in edge cloud support into our Casablanca release, which we expect by the end of the year. As you've heard from many of the other speakers, there are many places that could be called edge. It could be the customer devices themselves, or the customer prem, or the access network, or even central offices. What really characterizes the edge is the requirements around latency and bandwidth driven by use cases as opposed to one specific location. So we need to focus on different deployment scenarios to support these diverse requirements and the latency needed for the use cases. We do have an active group, about 20 different companies who have been talking about edge cloud and some of the requirements, and then how we bring that into our Casablanca release. For our third release for Casablanca, we've been considering a number of use cases, but for the purposes of an illustration, I'll just show you 5G today for mobile devices. At the top, we will have a centralized deployment of ONAP as we have today, but extending further, we may have another version of ONAP closer to the edge, the light blue box, and that may attach to an internal cloud, which could deploy VNFs and workloads on OpenStack, on Kubernetes, on VMware. We also want to partner with additional external cloud providers, and this could be Azure, Amazon, IBM, and many others. So we will need connectivity to the partner gateways as well for part of this. And when we went through ONAP, we looked at the requirements to extend this level of support. And there are two things that we need to do in our Casablanca release. The first is to extend the models to include our Edge Cloud IaaS and PaaS attributes. And this is to allow the workloads to be distributed, highly secure, configuration diverse, and cloud diverse, and also capacity constrained and performance and isolation aware. We've been putting a number of components in already, such as hardware platform awareness into the Beijing release, and so we'll be extending that in the Casablanca release. The second piece, which is new for us, is hierarchical central and edge architecture and functional interactions. The big stretch is adding the hierarchical orchestration. And we have been working on this, preparing for this over the course of the Beijing release. And we're putting together the finalizations for Casablanca to go. Our planning cycle will close in the middle of June, and then we'll be deploying from that point. So we have a set of work items that we are scheduling that will be available by the end of the year. And we want to engage, as one of the newer communities, we do want to engage with the wider ecosystem. We are at OpenStack this week. Today, just across in the East Building, we're having an ONAP architecture meeting all day. And we have an Edge Cloud session at 3:45 approximately this afternoon in room 11. You're welcome to join us there. Also, tomorrow we are presenting ONAP in edge computing, leveraging OpenStack at 1:50. So it'll be a longer version of the talk that I gave here, going into far more details about the use cases and some of the requirements. Also, I'd like to invite you to participate in our weekly architecture meetings, which are Tuesdays at 7 a.m. Pacific, and also the Edge Automation Working Group meeting, which are Mondays at 8 a.m. Pacific. All of the information is up on our wiki, and I'd like to call out the participating companies. The Edge Automation Group is being led by Sienna and VMware, with participation from about 20 companies, including major service providers as well as equipment vendors across the industry. So thank you very much, and I hope that you will all join us as we build out our Edge Cloud support.
Thank you, Chris, for the great summary on the ONAP Edge activities. And with that, this concludes our keynote block for the day. So I would like to thank all our speakers to come here and share their experience and what they are working on with you. I hope that you all found some areas that you're interested in learning more about. So I hope you're really excited. So go grab a coffee and look into the schedule. We have over 40 sessions in the next 2 days, forum sessions and working sessions. So I hope to see you around on those. Thank you.